Hey everybody, what's going on? Let's go ahead and jump right into it. So today we're going to be setting up localhost with HTTPS for your local dev environment. It's a 4-step process. Now, if you understand the concepts of HTTPS and SSL certificate issuance, go ahead and click the first timestamp in the description. Otherwise, stick around for a quick explainer about those two technologies, or processes rather. I stumbled around on Stack Overflow for a few hours, copying and pasting random code bits, and wasn't getting anywhere. Took a little bit of time to understand how this stuff actually works, and got it to work pretty quickly. So here we go. Let's dive right into it. HTTPS. So with normal HTTP, we're going to go ahead and send a GET request to the web server we'd like to visit from our browser. And basically that's just saying, hey, send me whatever you got, right? And the server gets a GET request for its certain path, and it understands, oh, anytime I get a GET request here, I'm going to send back some HTML, CSS, and JavaScript. Super simple 1-2. Now with HTTPS, we actually don't get data back right away. We first tell the server, look, we're trying to have an encrypted private conversation here. Please prove to me that you're actually Google. And so the Google server is going to send back its certificate, which we're going to call server.crt. And our browser is going to get this certificate, and it's going to check a list that it maintains, provided by Mozilla, provided by Google, whoever owns the browser and gives its updates. We're going to check that list and say, hey, do we have that certificate in our list already? So we're going to go ahead and see that this is the certificate for www.google.com. You can see it's got plenty of information here. What we're really interested in is who issued it. Looks like it was issued by Google Trust Services, goes by GTS-CA 101. So here in Firefox, in our certificate manager, you'll see in authorities, and we got here by going to preferences, privacies, and security. Scroll all the way down here to the bottom, view certificates. You'll go ahead and see here in authorities that we've got GTS-CA 101 here as an approved certificate issuer. Therefore, we are okay with this certificate because we trust the person that issued it. Now let's go ahead and assume for just a second here that we don't trust GTS-CA 101. We don't know who this issuer is. Well, this isn't a root certificate authority. This is something else. So GTS-CA 101 got their clout to issue certificates from a root certificate authority called Global Sign Root CA-R2. And to nobody's surprise, you'll see in here that we also have Global Sign Root CA2, a root certificate authority, as a trusted person. So the whole point of this is a chain of trust. So if we trust the issuer of a certificate, then we implicitly trust everything that's issued by that issuer. I know that's a mouthful. So anyways, we get the certificate from the server. We look in our list. We say, oh, we know who issued this. We trust them. We're good to go. We'll talk to this server. So that's what our browser basically decides to do. So our next step is in our browser, we're going to create a symmetric encryption key, not an asymmetric. It's not a public-private key pair. It's just a single symmetric key. And we're going to send it back to the web server. But we're not just going to send it in plain text, because then everybody would know what our encryption key is, and that's not good. So we're going to encrypt our symmetric encryption key with the server's SSL certificate. Because remember, the server's SSL certificate is a public key. So we encrypt our symmetric encryption key that we just made with a public key that belongs to the Google web server. The Google web server is going to receive this message, and since it's encrypted with its public key, it can decrypt it with its private key. Doing that, it's able to retrieve the symmetric key that we just created. And now we're going to use that for every single piece of communication. So now Google web server is going to say, oh, that's right. You also wanted me to send something to you, actually. So here we go. Here's your HTML, CSS, and JavaScript. But first, I'm going to encrypt it with that symmetric key that you just made. And now all our communication is encrypted with that shared symmetric key, and that's how we're able to achieve privacy with HTTPS. Excellent. Okay. So that those concepts aside, let's get into the 4 steps here. So our first step is we're going to create our own certificate authority. So how do we do that? Well, we need to create a private key and a public key. And our public keys are certificates. So let's go ahead and hop in a terminal real quick, and we will go through some of the commands here. So I'm just in any old directory. It doesn't matter where you are. You can see there's nothing in here. And we're going to start running some commands. I'm just going to copy and paste these in. So we're going to be using the OpenSSL utility. This is already on your Linux and Mac systems by default. For Windows, you can probably find it somewhere. And all this command is doing is basically generating an RSA key. We're going to call it rootca.key, and it's going to use 2048-bit encryption strength. Of course, we've got to come up with a password, so people get their hands on this key. You can't just use it willy-nilly. But since this is for localhost, we really just don't care. So we're going to make the password super simple. And you can see there's our key. Great. So now with our private key, we're going to use that to generate our public key, our certificate for our root CA. So here's the command for that. We're going to plug in that private key we just created, and we're going to say the certificate we're about to make is going to be valid for 1,024 days. Doesn't really matter. And this is the name we're going to call it. We're going to call it a PEM file. You can also call it a .crt. And now we've got to prove that we actually own the private key. So we're going to put in our password again. And now we can't just go willy-nilly creating certificates. They have to pertain to certain people and for certain domains. So we've got to fill in some information about what certificate this really is. So this information doesn't matter. This is localhost. We're not getting on the internet with this. So you can plug in whatever you want except for domain. So this last line, common name, what's your FQDN? We're going to put localhost because that's what this certificate is going to be used for. And then your email. We're never going to get emailed about localhost, hopefully. So we just put whatever we want. And now we've got our key and our certificate. So let's check them out. You can see our key says begin private key. So that's kind of what we would hope to see. And our PEM file is a certificate. So voila, we are good to go. We can go ahead and check that task off. Our second step is going to get our browsers to actually trust our root certificate authority, and they won't really ever trust us, but we still have to tell them about our certificate authority. So we can do this in one of two ways. We can attempt system-wide trust, and this depends on your OS. I'm on Manjaro Linux, and I'll go through a real quick 30-second on how to do that. But first, let's go through the browser way, because this will work for everybody. So we can actually tell our browsers to trust certain things. So if we go back to authorities, we can click the import button here, and this is for Firefox. You'll notice I'm in the directory where I just created my key and my certificate. This is my certificate file. I'm going to go ahead and upload that and say that it should be used to identify websites, which will pertain to localhost because that's the domain we're using. And boom, we're good to go. Now if we scroll down to our organization, which was random, looks like we passed it here. There we go. Okay, I forgot to delete my previous entries. I apologize, but you'll see one, maybe two entries for localhost, and that's what we want to see. So now we told Firefox about our plans here, so we're good to go. So let's hop over to Chromium, and this will work for the same for Chrome. You need to go to Chrome, Settings, Certificates, and under Authorities, you'll import, and we're going to import the same thing, that PEM file. And we're going to use it for identifying websites. We don't care about email or software makers or whatever. And similarly, if you scroll down here to the random org, we're going to find localhost. And it looks like I forgot to delete my previous entry. And here you'll see some information about our certificate authority. Great. So now we've created our, and I apologize for this blinking white certificate screen here. Let's just go ahead and get rid of that. So we've created our certificate authority and gotten our browsers to trust it, even though they really won't. We still got to let them know about it. Now we actually have to create an SSL certificate for our web server. So how do we do that? Well, first, this is kind of from the perspective of the server. We have to create a certificate signing request, which basically is just a file that's you present to a certificate authority and say, hey, certificate authority, can you please sign this for me and give me a certificate? And the certificate authority will sign it and say, yep, you're good to go. Here's your certificate. You can use this for SSL now. So we have our certificate authority. Let's make the CSR and then get our certificate. So we'll hop back in the terminal for this one. Let's go ahead and clean things up here. So, before I do that, let's go ahead and show you how to do this in Manjaro to get system-wide trust. Now this is going to be hit or miss, but you can copy the root CA PEM file, which is our certificate, to etc CA certificates, trust source anchors, and then you can run sudo trust extract compat, and it'll do its thing. Not really sure if this works or not, but you can give it a shot. So, anyways, Now we're going to go ahead and make that certificate signing request. So to do that, we're going to create a certificate signing request configuration file. And we're going to pass some configuration options that I just don't want to type out on the command line. So we're just going to attach it as a file to our command. And I'm just going to go ahead and dump in a whole bunch of stuff here. Just give me 1 second. And this is all pretty basic information, so we're going to use SHA-256, and we're going to use the localhost domain. Those are really the only 2 fields that matter aside from default bits, I guess. Everything else is not really that important. Let's go ahead and copy that in there. So now we have our configuration file. Now let's actually generate our certificate signing request. And just to make this a little cleaner, I'm also going to set a shell variable to give me the output of this configuration file. So all this command is going to do is I'm going to get the output of that file. So now we're going to put in this absolute beast of a OpenSSL command here. We'll go through what this just did in a second. So basically what's happening here is we're using OpenSSL and we're going to create a certificate signing request with a new private key that we're going to call server.key. And we're going to pass in some configuration options which are contained in the output of this configuration file, which is all this stuff. So let's go ahead and look in our directory and see just what we've got here. Configuration file, don't care about it anymore. Now we've got a certificate signing request and we've got a private key associated with that. So now that we have a certificate signing request, we need to get our certificate authority to actually sign it to get our certificate. That's our last step. But before we do that, we do need to create one more configuration file for our certificate. We're going to call it v3.ext. And I'm going to dump in some options once again. Now, a couple of these are browser specific, I believe. I will link some Stack Overflow posts in the description. I believe Firefox and Chromium both require this basic constraints line. And I think Chromium's picky about this line as well. But the bottom line is you just need the domain to be localhost. And that's what we've got here. So we're good to go with our config. And now we can actually use our CSR to get a certificate, to get our actual SSL certificate, what we've been chasing after this whole entire time. With all this verbose SSL stuff. So we're going to paste in one more command. Oh, and my apologies. That didn't work because we were looking for a root CACRT file. Let's go ahead and clean this up. So just give me 1 second here. We are using a PEM file. .pem and .crt are pretty interchangeable as far as I can tell. So here we're going to feed in our certificate signing request. Who's the certificate authority that's signing it? It's our root CA certificate. How do we prove that we have the authority to do that? Well, we provide the private key for which we'll be prompted the password in just a second. What are we going to create? We're going to create a certificate for our server. How long should it last? 500 days. What options or configurations do you want to pass into that certificate? The file we just created. So we're going to run this. We're going to have to prove that we own the certificate authority key. We enter our password. We don't get anything else, which is normally a good thing. And boom, we're good to go. So now, if we look at our server.crt, you're going to see it's our certificate. And if you look at our server.key, oh, whoops here, we are going to see a private key, and that is all we need. We have our certificate. So now we just need to tell our web server to use them. So let's go ahead and copy these over to our project directory, which for me is going to be right here. Now we'll overwrite those two. And let me hop into my application. So I'm using Node. This should work pretty similarly for any other project type. Basically, before we actually get our server to listen, we're going to tell it that it's got a public key, or private key rather, and a public certificate for SSL. And we're going to use those with environment variables so we don't commit them to Git because our production environment's likely going to have a different file path. But for me, it's going to be my SSL folder. You can see here I've got those two files here. And then when we create our server, we're going to pass in those options along with the app variable, which is where everything's defined. Our routes, our middleware, all our options, blah, blah, And then we're actually going to listen on port 3000, and we should be good to go. I've actually already got it running, so let's go ahead and test it out. So we've done that. We've told our SSL server, or our server, to use SSL. And the last step is to connect to localhost using HTTPS, because it will use HTTP by default. And let me tell you, that is a trap you do not want to fall into. So if you go ahead and type 3000, you're going to be met with nothing, because we're not running an HTTP server anymore. We're running an HTTPS server. So we need to preface this with HTTPS. Firefox will load it up. It sometimes will give you a warning, and it'll say, hey, we don't really trust this. Go ahead and accept that. And on Chromium, you will see the same thing, except one thing I forgot to mention on Chromium. So you actually need to go to Chrome, Flags, Allow, Insecure Localhost, and you need to enable this option. And then we can relaunch that. And now we will navigate to our server, and here's our little nice engineering landing page. But there you go. We're using SSL. Not secure because we don't trust it, but hey, it's SSL nonetheless. It's all the same to me. It's encrypted, baby.